Hello everyone, welcome to Codersarts. So today in this video, we are going to talk about R programming. This is the part 2 of your video of R programming. So in the previous video, we have seen an introduction to R programming language. We have learned about what is R Studio, how we can interact with R and write programs in R using the IDE called R Studio. We have also learned how it can be installed, downloaded in your system, and learned about the various inbuilt functions which are present in R. Along with the inbuilt functions, we had a look at the user defined functions as well, how functions can be defined by you giving a different name to it and accordingly can be customized. So along with that, we have also had a look around the inbuilt data sets provided by R, because R Studio, as you know, provides you with some inbuilt data sets for you to load the data. So we had a look along the introduction, history, the features of R basically, and the data operations also, which can be done using the inbuilt functions in R, and what kind of calculations and data manipulations can be done using the R programming language. So today in this video, we are going to learn and discuss about what are the different data types present in R firstly, and what are the different data structures present in R, how they can be manipulated, and some of the programs which can be done alongside with some practical demonstration in the video to make it more hands-on, so that you could get a clear picture about how data types can be used in R. So firstly, what are data types? As you know, any programming language has something called as data types, and data types can be either character data type, wide character, integer, floating point, double floating point, boolean, etc. But what are these data types? So data types are nothing but the means to identify the data of your variables. So you know, variables are assigned or allocated some memory. So whenever you're doing that, each of the variables in R is assigned with some data type. So that is why, in contrast to programming languages like C and Java, in R, the variables are not declared as some data types. You have to understand that whatever variables you are declaring, you don't have to declare them with some data type. The variables assigned with R objects. So that is why R is called as object oriented, and they are assigned with R objects, and the data type of the R object becomes the data type of the variable. This is an important line. You have to understand that the variables are assigned with R objects, and the data type of the R object becomes the data type of the variable. So there are many types of R objects. Now, what are the R objects? R objects, or the objects in R, are nothing but the data structures which are present in R. So the different data structures, or the means, the nothing but data structures in R, nothing but the data types only, because the variables in which you are storing basically are objects which are there, used for creating the different values of your variables. So those are stored as different data structures only. And what are those data structures in R? Those data structures are only going to identify the type of your data variables. So the different data structures in R are vectors, lists, matrices, arrays, factors, and data frames. You can have a note of all these 6 data structures in R: vectors, lists, matrices, arrays, factors, and data frames. In my previous video, I had shown you what exactly is data frame. Like, data frame is especially used like in pandas, also in Python or pandas. You know that data frames are used for storing any kind of a data set. So data frames are those which are used for storing any kind of data, especially whenever you have a tabulated form. So that is where data frames come into picture. So arrays, on the other hand, in any programming language, you have arrays. Similarly, a new data structure in R is called as a factor. We'll also be looking into what is the factor data frame, what is the factor data structure in R. Then there is vectors, lists, and so on. So when you see, the simplest of these objects is the vector object, and there are 6 data types of these atomic vectors, also termed as 6 classes of vectors. So when you talk about the vector in this particular document, it talks about the vector data structure, which is the first data structure you're learning in R. And that is, the data type can be of these vector data structure. The data type can be logical, numeric, integer, complex, character, or raw. So when I say you have vector, you must have heard about scalar on the contrary. So what is exactly a scalar, or what is a vector? Scalar is something which has only a magnitude assigned, but then a vector has both magnitude and direction. That is a common definition that when we talk about, scalar object and vector object. So when we say vector object, they are associated with some data types. Now, what is this data type? It can be a logical data type. Now, logical data type can be, example, true or a false. So when I say, this is how you assign, I've shown you in the previous lecture of mine that this less than followed by a hyphen symbol is used for assignment or used for assigning the value true to a vector v. So whenever you are printing the class of v, it is going to produce the result as logical. And why is it logical? Because it's going to produce or verify the data type of your vector. So the data type of the vector v is going to be logical vector, because true and false come under the category of logical data type. So you see here, the data type is used for identifying the type or the means to identify the type of your vector. So whenever you talk about the true and a false, a vector which is assigned true or false, the class of that particular vector is nothing but the logical class. So the difference between the nothing is there is not much difference, but we can say that class is nothing but like a data type only. So when you talk about because everything in R is considered to be objects and classes, as we know it's an object oriented language. So whenever you are going to find the class of a particular vector, it's nothing but going to give you the data type. So when we go to the next data type, numeric data type. So when I assign this v and assign it with 23.5 and print the class of v to know what is the type of your vector v, it's going to print numeric. Now why is it numeric data type? Because 23.5 is nothing but floating point, and any kind of floating point is, or any fractional number or decimal number comes under the category which is numeric data type. So that is why it's going to print the result numeric. Similarly, in this table you can have a look at 2l. Contrary to other programming languages like in Java or Python, you need not assign L over here. But in R, whenever you are assigning any integer value to a vector, you have to indicate it an integer with a L. So L is like, you have, it's nothing but to indicate that it is an integer. So it produces the following result, which is integer. Similarly, complex 3 plus 2i. So if you don't assign L, for example, you just say it's 2, it will denote the class of it as numeric. You want to try it out? So we'll just check what will be this, because this is something very new, because because the above ones, that is logical, numeric, they're common to any programming language. But then what is different over here in R, I'm going to show that practically here. Let's say in your R studio, this is your R studio, you have assigned the value 2L to the vector V. Now on running this, you get the class. It's going to display you the class of vector V, and the class of vector V is nothing but integer class. It's going to show you integer as it's showing in the console pane. Now say instead of 2L, you just gave us 2. Now you must have guessed it right. The integer, instead of an integer, the data type or the class of this vector will be identified as numeric. So let's run this. You will see the class over here as numeric. Why is it numeric? So you should now understand that in any programming language, you need not to specify whether it's L or with that suffix. But then in R, whenever you are assigning an integer variable and you want the data type to be an integer and not a numeric data type, then L has to be used. So in R, numeric data type is different from a integer data type. That is one thing you have to keep that in mind. So now that you have understood this integer, let's go to complex. Complex, any number is in the form of any number has an imaginary part and a real part in mathematics. So imaginary part is indicated by the I. So whatever number you are placing in front of your I, that is considered to be an imaginary part. And that is complex. It's because it's complex class, because the class of this 3 plus 2i is going to be complex, or 2 plus 5i is complex, because it's in the form of a plus ij basically. So nothing but you have a plus ib. Basically, you have the real part, which is 3 here, and the imaginary part, which is 2 here. So character. Now what is character? Character is something which is enclosed in either singular quotes or double quotes. So when you have anything like a number, you can either put it in single or double quotes. But then say you have true. Now true, if it was without any quotes at all, single or double, it was without any quotes, then it was a logical class. The class or the data type of this vector was supposed to be logical. But then as soon as you put true in double quotes, then the class of true is going to be character. You have to understand that it's going to be character. Now when you say raw, what is raw? So raw data type is nothing but hello is stored as this one. So when you are assigning this char to raw of hello to this vector, the class of that is going to be raw. So these are the different types of vectors. So let's have a look at the difference I was talking about basically. So let me clear this for you. This is control plus L is the command, by the way, as discussed in the previous video. So when I say over here, you are assigning, suppose vec is the name of your vector, you are assigning it with some value by double quotes, giving it false. And now you want to print the type. Okay, so on printing the type of the vector, as you have seen the command over here to print the type of the vector is nothing but the class of the vector. So data type is nothing but the class again. So it's nothing but inside the inside the parenthesis, right? Print class of vec. Now this is going to give you a, it won't give you a logical as the output, and it is going to give you a character data type. Why is it character data type? Because anything enclosed in singular or double quotes is treated to be character. Now instead of a double quote, say you have put this in a single quote. Let's check if this is going to give us the answer as character or something else. Is going to give it as character only. Now that you understand that you can either keep it in singular quotes or double quotes, anything will do. But then if you do not put it in quotes at all, then it will not identify it as a character vector. Rather, it will consider it to be a logical vector, because logical vector is the class which is either true or false. So that is a logical vector. These are the different ways in which you can understand what data type is, the different variables you are assigning in R. And there is no need to explicitly specify the type of your data whenever using in any program, as I'll be showing later to you. There is no need to explicitly define that your variable has to be in this data type only, or your variable has to be in that data type. So obviously you have to first understand that before you're declaring any data type, it is just that you have to assign it to some value, and when you're printing the class of that particular variable, then that data type or the class of that particular variable will be denoted by making use of the class command or the class function. So in R programming, the very basic data types are the R objects called vectors. As we have seen here, the first data type. So there are totally 6 data types in R, as you have to understand: vector, matrices, arrays, factors, data frames, and lists, as we have seen. So this was the vector uh, data type which we have understood. Now coming to what is scalar in R, we have understood what is vector, and these are totally the 6 vectors: logical vector, numeric vector, integer vector, complex vector, character vector, and raw vector. Coming to what is scalar in R. So scalar is nothing but whenever you're assigning this variable a to 9, this scalar can then be used to create a different scalar base. Scalar is nothing but a variable having, it's something like a variable with a value. So when you say b is assigned to a plus 1, that is nothing but 10, because a is assigned to 9. So 9 plus 1 is 10 will be your new value for the scalar. So any type of object can be overwritten. So this is the way in which the you can define scalars in R. So when you suppose you say objects need not be numeric also. So when I say you're declaring an object C and giving it a value of hello world. Now this object can create an object C of mode character rather than numeric. So when you call the class of A, the class of A was numeric because A was assigned to 9, and 9 is in a numeric class. But then when you assign C with hello world, as we have seen some example, it is going to give character data type. Why is it character data type? The class of this scalar is going to be character because it is enclosed in, it is a string form. It's not numeric, it's a string form which is enclosed in double quotes. So anything, be it a number also, you can even instead of false here, if a vector is given in a number something like 26.9, so the class of this vector should be a character type only, or the class will be identified as character data type because it is enclosed in single quote or in double quote. Now say instead of this you are assigning it as 23. Now what is 23? 23 will be numeric, but in other programming languages it will be integer. But then in this R, you have to understand there is another data type called numeric data type. Now say if you want to make sure that it is not numeric class, but it should be integer only, you should specify it with an L here. So when you say 23L, Now let's see the class of that. It's going to be integer here. Now this is a very important key difference that you have to understand in R, that the difference between integer data type and numeric data type. I hope you have understood how different are the different vectors present in R. What are the, identify the different means in which you can identify variables in R, and what exactly are the different types of scalars and vectors in R. So this will conclude your first lecture, which is about of this video, the first part of this video, which is exactly the part 2 of your R tutorial actually. And this was about data types in R. Now that you have understood about what are vectors, let's now understand about what exactly is a list. So coming to a list, which is your second second data type in R. So list is nothing but they are nothing but R objects which contain elements of different types like numbers, strings, vectors, and another list inside it. A list containing another list inside it is called as a nested list, as you might know. And list is created using the list function. In my previous video, if you remember, in one of the programs, when I was explaining you the last part of the video, I was explaining you write a program which of an area of a rectangle, and to calculate the area of a rectangle, and the area of a rectangle will be basically it was a rectangle class program which I created, and the program will be returning the area along with the perimeter of the rectangle. So whenever you want to display both the area and the perimeter as a single result or a single output, list was coming into a picture, because list is used for storing a sequence or a set of different elements of different types, and a list need not be homogeneous. If you see the difference between an array and a list, you will understand that list can be heterogeneous. So when I say heterogeneous, it can contain the elements of different data types. So as you see here in my screen here, creating a list. A list is created using the list function here. So when inside the list function, you can pass in all the different elements. Now this element can be a string form, they can contain numbers, they can contain numbers like 51.23 and so on. They can contain vectors also. So when you see C followed by 21, 32, 11, this is nothing but a vector. So this is a way in which vectors can also be used as element of a list. Then you have true. True is again a vector, which is a logical vector, as we have seen in the previous slide. True is a logical vector. So when you print list data, all the elements on executing the above code, all the above elements will be treated as individual entities of the list data, and this is how they'll get printed one by one. So when you see this, everything seems fine. But then when you see this one, 21, 32, 11, this entire thing is going to be considered as one single vector. And one single vector is one single element. So in this third line, you can see that 21, 32, 11 is going to be displayed as one single element itself of the list. So list can contain vectors inside them. They can contain again a list inside them, and so on. So this is the way in which you can print the list. So on printing the list one, if you see this one, list, and then it's containing 253. On printing this, you will see that it produces 253 as one element of the list, 21.3 in the next line, and sine. Sine over here is a function. You might have heard about the trigonometric functions like sine theta, cos theta, tan theta, so on. So sine is a function in R as well. So is going to give function of x dot primitive sine. This is the way in which it will going to be displaying the list. So let us work around with lists practically on RStudio. So let's say, okay, let me just create a new list here itself for you. List, and then if you see in this case of yours, list, and then inside you have a vector as well. So let's give a vector, let's give any number first, like maybe 24, and then give a character type data saying something like student. Then let's give a vector here, and C followed by the it can be a character, or it can be, let's say, instead of having numbers, let's put it as characters and see if it's going to take that or not. ABC. Now you can print. You can also yes. So on the next line, instead of writing print of list, you can just say list, and it is going to print you all the elements present in this list. And also one thing you have to understand, one thing I was missing here is that I did not write list here. So list function has to be used. Basically, whenever you're creating list, you have to specify it's a list. And you can give this a different name also. Need not be list. You can give it something like res list. Any name would work. And over here as well, since you want to print res list. And now on printing res list, let's see what will be the output of res list. As expected, you will see the output over here in the console window of yours. In this case, you will see the output of rest list as 24, which we have provided in the first line. 24, then the second line having student and the third line having ABC. So ABC is a vector and it is a character data type. It's a vector having all the characters in it. So A, B and C are considered to be character. In the example we were seeing, we saw that they were numbers, but then they may not be numbers always. They can be characters also. And instead of, let's say, we can add one more here. Instead of sign, let's add another element over here. Say you want to add tan. Tan is also a mathematical trigonometric function. So on doing that, you will see the fourth element of yours on the fourth line, like function of x dot primitive tan. It's a primitive data type. So all the trigonometric functions of yours like sine, tan, cos, then secant, cosecant, all that, cot, cotangent, and everything. They are all considered to be as primitive data types. So and hence they will be considered as function of x dot primitive followed by the type, which is whichever you're providing, like sine, tan, and so on. Now let's come to naming the list elements. Now that you have understood how we can create a list in R, now we can go to the next section, which is naming list elements. So whenever you're creating a list containing a vector, matrix, and a list, so what exactly is this? This is the way in which you are creating a vector. So when you say C followed by Jan, Feb, March, this particular first element of your list is nothing but a vector. So vector, in order to define a vector, to create a vector in R, this is the way. C, you use the letter C. Then in the bracket or in the parenthesis, you write all the in the basically the in the brackets is arguments to the function or arguments to the function C. You write Jan, Feb, March, or whatever elements you want to write. So that is the vector in which you're creating. So this list data is containing vector also in it. It is containing matrix also. So matrix is nothing but, as you know, it can be a 2D matrix, 3D matrix. Is nothing but a vector. Matrix is a collection of vectors. So matrix is having C inside it. So it's having a vector 3, 9, 5, 1, -2 and 8, n row equal to 2. So n row is nothing but to specify the dimensions of your matrix. So your matrix can be n cross an array, right? N cross an array or n cross an vector can be considered to be a matrix. So when you say n row equal to 2, it means the number of row is 2. So it's going to split this vector accordingly that you will get 2 rows only in your matrix. So when you split, like in this one, you have 6 elements. So on splitting this into 2 rows, you will have 3, 9, 5 in your first row and 1, -2 and 8 as the elements of your next row. This is the way in which matrix can be created. Then list is nothing but just specify list over here. So you see this list data is containing another list inside it. So that is nothing but a nested list, because list data is containing another small list, which is list followed by green 12.3. These are the different elements present in the inside list or the inner list. Now giving the names of the elements in the list. So whenever you're giving names to the list data, when you do this, you can assign it with the vector first quarter A matrix inner list. These are all the different elements present in your list and you're assigning that to names of list data. Once you do that, in order to print the list or to show the output of your list data, this is how on doing it, print list data. When you execute the above code, it produces the following result. So which is first quarter, which is Jan, Feb, March. This is your nothing but your output of your first quarter list. And the next on doing matrix. As I was saying, 3, 5, -2 is going to be your first row. And whereas next one 9, 1, 8. So whenever you're printing the matrix, you will understand that sequentially it's going to print it in the vertical format. So when you write 3, 9, 5, 1 and so on, it's going to write print 3 and then in the vertically go to 9. It's not going to write 9 over here, because you have mentioned n row equal to 2. So the number of rows should be 2. And in that order of vertical, you will see that 9 is present here, then 5, 1 and so on in whichever sequence you have provided the elements of your matrix. So on doing this, then next is your inner list, which is green. You have seen here green and 12.3, which are the elements of your inner list. So this is the way in which it gets printed. Let's have a demo of this and to see how exactly in our R Studio as well. And we can modify this a little bit for you to understand. So let me erase this. I'm just clearing it every time so that Control L, yes. And I'm also clearing these variables so that any kind of confusion will go. So just to clear this, you can make use of the brush command to clear all your workspace variables and to make the environment empty. Once that is done, okay, let's copy from here itself all the list elements. So because you can see that this is a list containing a list inside it. So whenever you are doing this, let's, for example, this is the, so on pasting it on your R, okay, it's not getting pasted. So we can, of course, now that you have understood how list can contain a list, we can make our own list as well. So let's make a list like outer list, which is having, you making use of the list function. And inside this, you can create a variable, a vector. So in order to define a vector, you use the C function. C, and inside that 3, 5, 8, something. Then next is after vector, a matrix can be used. And matrix, you can give any numbers. So for example, say 4, 8, 9, 6 or 7. Yeah, 4, 8, 9, 7. And then n row equal to, you can have 2 for now, 2 rows only. And once the matrix has been created or defined by you, this is the way in which you can define your matrix. And also one more thing, matrix, since it is having nothing but a combination of your vectors only, you have to again enclose it with a C as well. So you have to use a vector as well as an argument to your matrix. After you have done that, then you can create another inner list here. Let's give another inner list, and the inner list need not be specified explicitly with the name, but we can just give it, create an inner list by making use of the list command or the list function, and maybe add a character as well to make it a heterogeneous kind of data. That is, since the data need not be numeric only, we can use different combinations of different data types. So instead of just sticking to numeric, let's make it little more heterogeneous and mixed combinations of data types. So when we say list A, okay, let's say ABC and then XYZ. Once this is done, close your list, outer list, and now you can print your outer list. So let's say print outer list. Yes, so once this is done, on running it, you will see, as expected, you will see your outer list 358 as your first element of your outer list, then your the matrix. As I've told, it is going to print all your elements in the vertical format. So 4897 is the way in which it's going to print your elements sequentially. Then you have an inner list, which is ABC XYZ. So ABC is the first element of your inner list, and the next element of your inner list is XYZ. That is why you can see under your third element of your outer list, you will see 3, 1. That is nothing but in the first row of your third element. Nothing but the first element of your third element. That is nothing but ABC. And in your third element, or the which is a list, nothing but the list, the second element of your list is XYZ. So it's denoted by 3, 2. I hope this makes it clear how to make use of inner lists. So this is what you can do in R. Now, once this is done, now that you've understood this, let's understand how we can access list elements. To access list elements is nothing but we make use of the slicing operator. So whenever you want to slice or access any element of the list, it can be done by accessing it via the index of the element in the list. So whenever you're specifying the index, that is 1, 3, it is going to access the first element of the list because you have specified list data at 1. So the first data of your list over here, and this is a list containing a vector, matrix, and a list. As we have seen, it's nothing but the previous copy of the previous list only. So when you do this, the first element of your list is Jan, Feb, March. And one important thing you have to understand in R is that unlike Python and Java, R does not start your indexing or your counting with 0. Always the indexing or counting in your R in our programming is starting with 1 only. So whenever you specify you want to access the first element of the list, you specify it with a 1 only. Otherwise, in Python and Java, we have seen in order to access the first element of the list, we specify list data at 0. But in R, we don't do that. If you want to access the first element of the list, just specify list data at 1. So when you use the square brackets like this, it is used for accessing the elements of your list, or nothing but this nothing but to access elements or a slicing operator. So when you're doing that, and inside the brackets, you have to mention the index of your list. So once to access your third element, you can do that. All elements will be printed. So when you want to list the third element of a list, you will do list at 3. Now list at 3 is going to, what is the third element? The third element is green 12.3, which is nothing but again a list. So all the elements of your third element, which is nothing but a list, all the elements of the inner list will be displayed. So green will be displayed in the first line. Second line, you will see 12.3 displayed. So accessing the list element using the name of the list. So you need not always access it through index. Another way to access it is through the name of the list. So name of the element is nothing but a dollar sign is used for accessing it via the name. So the name is over here is a matrix. So whenever you're giving names to the elements in the list, like in the second case, this one, names of list data, you have given name to your first vector as first quarter, matrix as a matrix, and this list green having 12 green and 12.3, the name is given as a inner list. So if you want to access suppose the matrix, so it's you just have to give a dollar as the symbol, as a dollar operator to access the list element using the name of the element. So the name of the element is a matrix here. So when you say dollar a matrix, it is going to give you then the all the elements of your a matrix. Now what is a matrix? It is C, this one only, the vector 3951. So this will be given as output. So when you see here, this is what will be shown as output to you. So this is how in which you can access your list elements. So let's just have a look into, in our case also, when we have this outer list, say that you want to access you want to print outer underscore list. This is the way, square bracket, you want to access, say, the second element of your list. So to access the second element of your list, just run this command. You will see outer list at 2. So the second element of your list, which is a list, which is a second element, which is the matrix. Because the vector is your first element, the second element of your outer list is the matrix. So the matrix will be displayed as output to you. 4987. It's a 2 by 2 matrix, by the way, because 2 rows and 2 columns. So this is the way in which you can access your elements in the list. You can also provide names and access the elements of your list, as we have seen. Next, coming to manipulating the list elements. So what is meant by manipulation basically? Manipulating list elements is nothing but adding, deleting, updating the list elements. So when we say you can add and delete elements only at the end of the list, you can also update any element. Now when I say this list elements are mutable, so there is a term for in programming terms, there is a term, if anything can be updated, or the value or the data present in a variable can be updated, that is termed as a mutable data type. So lists are mutable because they can be mutated or they can be updated. The elements can be updated. So let's copy paste this and see it live, what will be the output. When you see this, you will see all the expected output like this, as is shown here: new element, null, updated element, and then we'll go into the merging of the list. So let's go to the R program of ours and let's run this, which is for creating a list containing a vector from here. Yes, as expected, you will see that upon running this list data, you will see list data firstly has been added to your environment variable here, and you will see here, this is the way in which you can basically perform manipulations in addition, add elements to the end of the list, delete them, or change their values. So when you see here, from here, create a list containing vector, matrix, and a list. You have created a vector here, matrix here, and then the list here. To give names to the elements, you have given the names as well. And then whenever you are, changing the fourth element of your list data, what is the fourth element? Fourth element over here, the first element is the vector, second is matrix, third is list. Then fourth element, you are assigning it to new element. So in this way, you are adding a new element to your list, because initially there were only three elements present in your list. There was no fourth index at all. But when you are assigning a fourth element here, you can see on my screen, a 4 I have assigned. So whenever you are assigning a new index, the R program will understand it to be a new element. So new element will be added to the end or appended to the end of your list. You will see new element here. You can also remove the last element. In order to remove your last element, you have to just assign your fourth element or assign the last element of your list to null. So null means nothing, right? It means you are deleting it basically. So this is a deletion operation in which you can do in R. And now you can, in order to print your fourth element, which has already been deleted, you can just do print list data at 4. So in this way, the fourth element present in your list data will be printed. So on doing that, null, since you have assigned it to null, null will only be displayed as output. That's why it says NA. Dollar sign with an NA, because dollar stands for name and you have not provided any name to it. So it's NA. Now to update the third element. So list data at 3. Whenever you list, when you see the list data, the third element of your list data is a list again. And whenever you are assigning your third element with updated element, you can also update your list. So your inner list, which is this list green, which is again an element. The third element is green 12.3. That gets updated to updated element because you have assigned updated element to your list. So whenever you're doing that, it gets updated. In this way, your inner list will not be a list now. It will no longer contain green 12.3. Rather, it will contain just updated element. To verify everything, let's say you want to just print the list elements one by one. So when you do list data, you will see all the elements of your list now. The inner list, which is updated element. Then you see here the list data, which is first quarter is Jan, Feb, March. It is left intact, or there is no updation performed on your first element. In your second element, this was a matrix, which is again intact. There is no operation or manipulation updation provided on the second element. The third element, which was updated, or the third element of your list, which was changed basically to updated or basically to updated element, that will be changed, and your inner list will now be converted and transformed with a new name, which is updated element. In this way, you can perform all your updation operations on your list. Now that you've understood how lists can be updated, elements can be updated, let's learn about merging lists. After merging lists, we will see how to convert list to vector, which will conclude your list data structure in R. Now merging lists, as you would know that any you should always in Java be it or C++, there should always be some merging or some concatenation operation. That is nothing but you can merge two data structures into one and so on. So whenever you have two lists, you can merge them together or you can concatenate them together. Okay, so in order to concatenate two lists together, it's simply just making another list. Just instead of merge dot list, you can give a different name. Suppose you have list 1 and list 2, you can place all the lists inside one single list function. How do you merge them? Just by writing C is, as you know, is the as we have seen, it's a function for creating a new vector. So a new vector can be created of the two lists. In this way, list 1 and list 2 will be merged together. So on printing merge dot list, you will see the merged list, which is containing 1 2 3 and sun, mun, dew as the elements of the list. So we execute the above code and you will see 1 2 3 sun, mun, dew as the two lists. Let's try it out practically. So for example, this is the console. Okay, just skimming through this now. To merge two lists. So for example, let me clear this entire thing because it's something very different we are doing now. Say in you have list 1 equal to list 139. Okay, 139. Okay, and list 2. Okay, instead of 139, we can also add one character type also to make it more homogeneous, heterogeneous, having different data types A, B. And list 2, which is having something else in another inside inner list also we will include in this inner list, say A, B, C, X, Y, Z. List is there, and then we will give some value 5. Now you want to merge. No, so for example, this third list will be merge underscore list. This is the merge list. And in order to merge two lists, just you have to make use of the C function or C command here. And then C inside that you have to just give list 1 and list 2 as the arguments or as the parameters. So when you are doing that, now you can just print your merge list and you will see all the elements of your list 1 and list 2 being merged and printed in your merge list. So on running this, as expected, you will see the output in the console window. Let me expand the console window view. See, we have executed this above command, merge list, this one. And on merging, printing the merged elements of the list, now you will see that the merged list will contain 1, 3, 9 in separate lines. And then you have, so totally how many elements do you think it will have? It will have 3, 4, 5, 6, 7. It should have 7 elements. And as expected, you will see 1, 2, 3, 4, 5, 6 and the 7 elements. So 7 elements. But one peculiar thing you will observe that in the sixth element of your list is nothing but containing a list having two elements. So it's nothing but an inner list. So this inner list is again subdivided, or basically the sixth element is subdivided into two elements again. The first element of your list is having ABC. The second element of your list is having XYZ. So this is the way in which we can merge lists. Nothing but by merging two lists and adding them as arguments to your vector function. So I hope you have understood how two lists can be merged in R. Now that you have understood this, let's understand how to convert list to a vector. So list can be converted to a vector so that elements of the vector can be used for further manipulation. No, sometimes there are cases where lists do not work and you need to convert them to vectors to perform some manipulation. Some special cases might occur. So in order to do that, you have to pass your list as input and you have to make use of the unlist function. Unlist function, as the name says, it is going to basically it will convert your list into something else. It is just going to unlist it, or basically going to change your data type into something different. Change the data type of your list to something different, and that different is nothing but a vector. So it takes the list as input and produces a vector. It cannot produce a matrix, array or something. Unlist is only used to convert your list to a vector. Okay, you have to understand this. So let's understand this. You're creating a list. This is a list, and as I've explained in my previous video, that 1 to 5 colon over here is used for giving a sequence. So whenever you want to generate a sequence of numbers, it is used for colon operator is used for generating a sequence. So 1 to 5, all the numbers from 1 to 5 will be printed here, 1, 2, 3, 4, 5, because this is the way in which you are creating a list. Similarly, 10 to 14, all the numbers from 10, starting from 10 and ending to 14 will be printed. 10, 11, 12, 13, 14. Converting the list to vector is using the unlist function here. So whenever you're writing and assigning to vector v1, so v1 is assigned to unlist of list 1, all the elements present in your list 1, which is 1, 2, 3, 4, 5, will be converted to a vector and stored in v1. All the elements of your list 2, which is 10, 11, 12, 13, 14, will be unlisted or converted to a vector and stored in v2. When you're printing v1 and v2, you will see all the two vectors here. Now you can add two vectors. So vectors, you have to understand whenever you want to merge two vectors. So whenever you are merging two vectors, it is nothing, merging two lists. You have just used the C function as we have seen here. You have made use of the C function to merge two lists. But unlike that, in vectors, you can add two vectors. Like, in mathematics or in you must have studied in vectors, matrices and determinants that vectors are such values which can be added together. So in order to add two vectors, you can make use of the plus command or the plus operator here. Okay, so whenever you're just adding two vectors, that is v1 and v2, you will see 11, 13, 15, 17, 19 as your two as a result vector. So you basically adding two vectors is going to add individually the corresponding elements of your vector. So 1 plus 10 is 11, 2 plus 11 is 13, and so on. And as you can see, 5 plus 14 is 19. So individually adding the elements of your two vectors is going to give a resultant vector, which is nothing but the sum of the individual vectors. So that was all about it, how you can create list and unlist them. Okay, already no need to copy this. Already we have a list. So we can just say how to convert that list and give it a vector. So let's do that. Instead of printing merge list, let's do, for example, a new vector, right? We are creating a vector. So vector something, vector new equal to, since you're unlisting it or converting that list to a vector, let's say unlist and unlist the merge list, because merge list is having both list 1 and list 2. Let's unlist the merge list and print the vector new. On doing this, you will see vector. After doing the unlisting here, you will see on my end of my screen, you will see on printing the vector 139 AB, ABC, XYZ, and 5. So this will be the all the elements of your vector basically. All the elements of your vector will be displayed here. In this way, you have successfully converted your list to a vector. Now, I hope you have understood about the vector data type and the list data type in our programming language. I'm sure that I have made the list, all the data operations which can be performed in a list very clear to you. Now let's come to the next data type in R, which is nothing but a data frame. So data frame is a table or a two-dimensional array-like structure in which each column contains values of one variable and each row contains one set of values. So let's directly begin the program so that simultaneously you will understand. Some points you might understand, or the characteristics or features which you have to keep in mind for a data frame is that the column names should be non-empty. Okay, so when you see this example on my screen, when you're creating a data frame, data.frame is the function. Like you have seen for list, you have made use of list function, and for vector, you are just using C. So data frame is nothing but a combination of your vectors only, because you can see emp id is nothing but a vector having all the elements from 1 to 5. Similarly, emp name is nothing but a vector having all the names of the employees. Salary is again a vector having all the salaries of these employees. So nothing but a combination of vectors is a data frame, and it's a two-dimensional array-like structure. But then a matrix is different from a data frame, because a matrix will not give a something like a tabular format. That's why it's very important to understand whenever you have a CSV file or a data to be loaded, you have to use a data frame only. Like I was explaining you in this case, read.csv is the command to load any kind of data set into your R environment. So if you have a CSV data like cloth size.csv, you can load it into your DF, DF, which is the data frame variable. So in this way, this is nothing but a tabular form only. So read.csv will store it in a data frame. So as you see, as.data.frame, as is the command which you are converting basically, and as you basically lapply is for applying any kind of function. So if you're applying a function, say normalize, it is going to apply in every row of your data frame. So in every row of your data frame, this normalize function is going to be applied. But if you want to not apply it on every row of your data frame, you can just write C followed by the vector. So normalization will be done on this particular vector of your data frame. So as.data.frame is to convert your data frame into, or convert any vector of yours or any data type, a different data type, to a data frame. This is a way. And data.frame is the command for you in order to create a data frame in R. So if you see this, to create a data frame in R, and all columns should not be empty. They should be non-empty. The row name should be unique. The data stored in a data frame can be numeric, factor, or character data type. So you can have any type of data type, and also each column should contain same number of data items. So that is something you have to understand. Now that you have understood how to create a data frame, let's see here, and I will paste this command over here. So say let's paste this in our R studio and see how the structure of your data frame. After executing this, you will see this is actually the structure of your data frame. You must be familiar with the databases, right? So databases are nothing, relational databases, especially whenever you're dealing with tabular data or tabular data having rows and columns. That is where data frame comes into picture, because everything which you're providing over here, emp id, emp name, salary, they are considered to be the column names. Start date and string is factors. They are nothing but column names. But then the rows over here are nothing but the elements of your vector. So elements of your emp id. So all the elements like 1, 2, 5, and then Rick, Dan, these are nothing but all your rows. So the values of your each row is going to be specified when you are assigning them as elements of your vector. So once this is done, and this particular line, which is strings as factors is equal to false, it is used for checking if you want to basically keep your string as a factor or not. We don't want factor is another data type, by the way. I'll be explaining you that right after data frame. Factor is another data structure data type in R, where if you want to identify, if you want to make your string to be identified as a factor, you can either declare it to be true or a false. Over here we have made it false. And on printing the emp.data, which is nothing but the data frame. The name of your data frame is m.data. On printing that, you will be getting this is the output. And to get the structure of the data frame, you can do it by using the str function. Str function will give you the structure of your data frame. Then this is another str of m.data. You see the above code, this will be the structure of your data frame. Its structure will be containing your data type followed by all the elements. It will also contain data frame, a holistic view basically. Like how many rows are present in your data frame, how many columns. So observation stands for number of rows, variable stands for number of columns. Similarly, whenever you're using the date data type, so start date is having elements which are containing all dates. So whenever you want to convert your string into a date, as dot date is the function. You have to identify this. You can make a note whenever I'm explaining you. You can make a note of all these small, very important notes you can make, so that you can identify and understand that whenever you are coding any R program or creating any data frame, you have to make sure that in order to convert from one form to another form, these small functions are something which come very handy to you. So as dot date is for converting into a date format from a string format. And then whenever you're using vectors like this, you can assign them to different column names here, and then print the data frame of yours. To get similarly, as you have seen, str is a command to get the structure of your data frame. Now to get the summary of your data frame, summary is the function. Summary and str are inbuilt functions, as we have seen. Inbuilt are nothing but they are already provided by R. They are not user defined functions, they are built-in functions. So if you have seen here, and in order to print the summary, just write summary of m.data, and the summary of your data will be printed. Now what is summary? Summary is going to give you the statistical measures of your data frame or of your data. So if you have a data set in CSV form and you have loaded that data into a data frame, as we have seen here, we have loaded that into a data frame df, and on performing summary, you will be getting all your statistical measures. So when I say statistical measure, it will be giving you the mean, median, mode of your data. Right, these are all the things. The minimum value of your all the values present, then the minimum, first quartile, median, mean, third quartile, maximum. These are some of the statistical measure tendencies it is going to give you on performing summary operation on your data frame. So let's first finish this, and then we will understand what is how to extract data from a data frame. This is one important point you have to understand, how to extract from different rows, 2 rows, third row, and for some nth number of row. How do you expand a data frame? By adding a column, adding a row to your data frame. How R bind function, and to add a column you have something called as basically how it can be added by making use of the dollar command to add a new column to your data frame. How you can basically concatenate or append a new column to your data frame. How you can bind or add a row to your data frame permanently by making use of the R bind command in R. And how do you merge or bind two data frames by making use of R bind? Because the data frame is again nothing but an n-dimensional array only. It's nothing but a vector combination or collection of vectors, as you are seeing here. So these are some of the different functions here you must have to be familiar with. So let's practically, I'll just demonstrate this for you. Let me clear this. Okay, this was the previous thing. In our new script, let me add the code. Okay, say that you have this particular, okay, let me clear this, Control plus L for clearing your console. Creating a data frame. So this is a data frame of yours, m.data, right? As we have seen, you will see a value that is m.data, which is a variable, and their values. 5 observations means 5 rows, and 4 variables means 4 columns. Now, what are those 4 variables? 4 variables are nothing but emp id, emp name, salary, and start date. These are the 4 columns of your data frame. You can see this here, and 5 rows have been added. Why are there 5 rows? Because 1 to 5, 1, 2, 3, 4, 5, Rick, Ran, and so on. And also understand that you have to always keep this particular point in mind, that each vector should have a similar size. You cannot just, it cannot be the case that emp id has 5 numbers but emp name has only four employees. So what about the fifth employee? There should be some name assigned to him, right? So you cannot keep it any inconsistent size. It will give you an error. Always make sure that they are of similar size. So similar number of elements should be present in each row. So if we say start date, they should have start date column should have 5 elements, and salary should have 5 salaries. It cannot be that you have only 2 salaries, or you can have 7 salaries. It should be the exact number, and the same number has to be maintained consistently in your data frame. So this is your data frame basically. Now let's say instead of print m data, let's say you want to get the structure of your data frame. See, this is str of m dot data. This is going to give you the structure of your data frame. And then let's say instead of structure, you want to get the summary of your data frame. Now, summary of your data frame is going to give you your mean, min, this is all. So minimum of your data frame will be given to you. Then first quartile, median, mean, third quartile, and maximum. These are the different ways in which you can basically manipulate your data frame in these way by making use of these R commands and R functions. Now let us understand how do we extract data from a data frame. You have created a data frame. We have already seen in R Studio Live that how to create a data frame. Now we want to extract specific columns. You have seen how to access specific elements of a list and a vector. But what about a data frame? To extract specific columns of your data frame, you should write data.frame, then emp.data, which is the name of your data frame, and a dollar symbol. Now dollar symbol comes into picture because you want to extract specific columns by their name. So when you have given names to different columns, right? If you want to extract, say you want to extract only the employee number, so you have to specify the dollar symbol followed by the employee number, then emp.data, which is the name of your data frame, and then dollar symbol followed by the name of the specific column you want to access or you want to extract. So if you want to extract salary column, you have to specify dollar symbol followed by the salary. That is going to give you the it will give you this whatever specific columns you want. So the result will be only emp.data. The name, that is the employee name, only will be given to you, and the salary, because you just want 2 columns out of all the 4 columns of your data frame. You just want to access, or you just want to extract 2 specific columns, and the 2 specific columns are nothing but the employee name column and the salary column, and those will only be extracted out of your data frame. This is something very similar to how you must have done in SQL. See, you have a big chunk of data, humongous data, and out of that humongous data, you just want some specific column or specific columns to be extracted. This is the way in which you can do it. So we have this data frame of ours, and let's say we want to extract only some data frame. So let's say let's assign it to a variable result only, and let's say result and emp dot data. Since you are storing that as a data frame only, let's say data dot frame and in the bracket emp dot data, which is the name of your data frame, then dollar symbol, and say if you want the employee ID and the employee name, only these. Now you don't want the salary, you don't want to know the start date, you just want to get the employee ID and their employee name only for some personal purpose. So on doing that, you can just specify like this, and maybe emp dot data, dollar symbol, and let's say emp name, and print result. On running this command, you will see, as expected, in your console pane, you will see that on executing this, you will just get a data frame having 2 columns, the employee ID column and the employee name column, and the salary column and the start date column will be removed or will not be displayed to you in your filtered output. This is the way in which you can extract specific columns of your data frame. I hope you have understood this by this practical demonstration of yours. And once this is done, let's understand now now this was one way in which you can extract specific columns. Now how about extracting specific rows of your data frame? Now to extract specific rows, you can just make use of a simple colon statement only. This is very self-explanatory. So say if you want to extract the 3rd and the 5th row with 2nd and the 4th column. So for doing this, you can just say basically, okay, this is for the above case. So if you say okay, this one, extracting the first two rows and then all columns. So first two rows means 1 to 2, because 1 to 2 means first two rows will be included, and all columns means you don't have to specify anything. R will just understand that all the columns have to be needed. So you will see only first two rows printed and all the columns will be displayed in a data frame. Similarly, if you want to extract the third and the fifth row with second and the fourth columns, then you have to specify 3 is to 5. 3 colon 5 comma second and fourth means 2 colon 4. Let's see that. Sorry, 2 and 4, because it's not saying that the columns should be from 2 3 4. If we do 2 colon 4, then third column will also be included, but we just want 2, that is the second column and the fourth column. So we can make use of a vector here and just say 2 comma 4, so that the second column and the fourth column will be displayed, and third row and the fourth row and the fifth row. So only the third and the fifth row will get explained, whereas in the previous case the first two rows, since we wanted the first row as well as the second row, that's why we had made use of the colon. But then in the next case, if you see, we want only we don't want the third column, or we don't want the fourth row, so we can specify them only the third and the fifth row by making use of a vector here. So C is the function, as we have seen, to produce a vector, and then the second and the fourth column can be mentioned here, C2 comma 4. This is how you can basically extract the different ways to extract rows of a data frame. So once I will just demonstrate it to you, this function. So that once if this is done, then we will get into how to expand the data frame by adding column or adding a row. And that is very similar. For a column, we have seen how to when we were seeing how to extract a column, we got to understand the dollar command, right? The the dollar symbol. So dollar symbol plays a very important role whenever you want to access or add any column. So that is where you're using a dollar. But then dollar is something like your concatenation only, or concatenating or expanding your data frame with a column. But then when it comes to rows, you have seen there was something different. Instead of a dollar, we have like we have to like make a row here, a new vector, and then append it to the result row. But then if you want to basically add a row, then rbind is the function, which comes very handy whenever you want to merge two data frames, or you want to merge or bind any rows or add any rows to your data frame. So let's execute this, and then we will get into expanding data frame or adding rows basically. Okay, so this is the previous only, print m dot data. Instead of print m dot data, you want to, as we have seen, instead of printing the data, you want to just basically extract the third and the fifth row. So how can that be done? So if you see in this case, extracting third and the fifth, instead of third and fifth, let's remove this line and just say, we can remove the comment here, and just if you, instead of third and fifth, let's say we want to access the first and the fourth, and the column can be 1 and 2 column, or like first and the second column. So you can say 1 is to 2. 1 is to 2 for ensuring that 1 and 2 both, because they both are consecutive, they both can be displayed together. As expected, you will see this is your resulting data frame having only the employee ID and the employee name. But then the employee ID and the employee name, which is there, which is displayed to you, that will only contain only the first row and the fourth row. So the first row will be mentioned, fourth row will be mentioned. But then the columns are only the first and the second columns. And the first and the second columns were employee ID and employee name. Say instead of the first and the second columns, you want only the last one, the salary only. And if you only want the salary, you can just say create a vector, and then the salary is the fourth column of yours. So if you just want to know the salary only, you will just see the salary being mentioned. Sorry, the date. The last one is the start date. So instead of start date, you also want the salary, for example. So say here, you can mention the salary along with the start date. So you can see the salary and the start date in your output. In your output, you will see the first and the fourth row and then the two columns, salary column and the start date column being mentioned. So this is some of the ways in which you can manipulate your different data frames present in R, and data frames come really very handy whenever you're dealing with data analytics, because all your data in tabular format will be stored in data frames only. Now that you have understood how to do this, let's understand how to expand a data frame. So to add a column to your data frame, basically you can just add them using a new column name. And how can that be done? Just mention the data frame name, the dollar symbol, and the new column name. So the new column name you are adding is the DEPT, or the department column. So you can just write DEPT here and then assigning it to a new value. The new value can be any data frame, but make sure that it's containing the vector you are assigning it to. It should always contain 5 elements, because if you mention only 4 elements, it will throw an error saying inconsistent size. As you have mentioned everything as 5, that is employee ID as 5 and the employee names as 5. So you have to mention that the vector, that is you have created the DEPT column, basically the department column, that is containing a vector having 5 elements. So that is what you can do here. So let's understand how column can be added. And we will run this entire command. As expected, you will see your data frame over here with the DEPT column. Now let's understand, since I was saying that it should only have 5 elements, instead of finance, we will just remove finance and see what kind of an error will be produced. Now we are getting department also, because we have manually added department as the 5th column by making use of the dollar command, the dollar operator here, and then added it to append with this vector having all these 5 departments. But if you have only 4, it will show this error. I have wanted to explain it to you, that if you are not giving any department, what error will be shown. So this is the error you get. Data.frame, it will say that replacement has 4 rows, data has 5. That is, the data frame of yours is nothing but data. It has 5 rows, but then replacement has 4 rows. What is replacement? Replacement is your updation, and the updation is nothing but the new column you have added. Your new column DPT should actually contain 5 elements, but it's not containing 5 elements since we have removed the 5th element. Now you can add any 5th element to it. Say you have IT, operations, HR, and let's say you something like sales. Sales is the 5th element. Run this and you will see your data frame as expected. You will see the department with the sales column as mentioned here. So these are different ways in which you can add columns to your data frame. Now that you have understood how columns can be added, rows can also be added by making use of the rbind function. So you can add rows to your existing data frame using the rbind function. And if this is your data frame, if you go to this last 2 lines to bind to data frame, so whenever you want to bind to, this is your first data frame here. You can see here your first data frame, a second data frame, a new data frame with emp.new data as the name, and emp.data is your first data frame. If you want to merge 2 data frames as such, then you can bind the 2 data frames by making use of the rbind function. That is nothing but rbind m.data, m.new data. This is going to give you a merged data frame or a binded data frame having all the columns, basically all the columns of both the data frames together. Right? So if you see your first data frame is also having the same column names as your second data frame. And what about the elements? The elements, if you see in your first data frame, those are 1 to 5 in your employee ID. So 1 to 5 is there, and for your second data frame is 6 to 8. So they are vertically being merged together. So whenever you're using rbind, they are vertically being merged together. So this is one way in which you can add rows. Add rows nothing but binding or merging to data frame. So this is something to add rows permanently to an existing data frame. We need to bring it in the new rows in the same structure as the existing data frame and use rbind function. So rbind function is used for merging the rows of the 2 data frames in a vertical format. And whenever you want to add new rows, you have to make sure that it is added in the form of a data frame only. So you have to create another second data frame having the same names of the rows, the same names of the columns as well. And of course, the rows observations can be differently set by you. New values can be assigned. And this is the different way in which you can merge it with the existing data frame to create a final merged data frame as such. So I'll paste this command for you to understand, so that how can two data frames be merged. So basically R bind is the function where first data frame will be passed as argument, the second data frame will be passed as a second argument, and both data frames can be binded together, or by making use of the R bind function they can be merged together, and on printing the merged data frame you will get a merged data frame having the rows from both the data frames. The column names are the same, but then the rows are the different. So let's click on run, and on clicking on run you will see your merged data frame like this: emp id, emp name, so on, department, and then they are containing the totally 8 rows will be there, because your first data frame has 5 rows, your second data frame has rows from 6 to 8. So all the rows from 6 to 8 will also be included, and all the values you have assigned in your second data frame also will be merged in your merged data frame or in your final data frame. I hope I have made the concept of data frame as well clear to you. Now that you have understood what are data frames, how to basically deal with data frames, data types in R, there are two more data structures you have to be familiar with, which we'll be covering in the next video of ours, where I'll be explaining you the factor data type, which is the data structure in R, how to add rows using the R bind function we have already seen. I'll also be explaining you how in different cases are there for, while you are adding, although you can add your new rows by making use of the R bind function and adding merging two rows basically, but there are some kind of different cases called as joins. Basically you must have heard about the joins in SQL. So similarly joins also are a function in merge only. You can make use of joins in your R as well, R programming. So I'll be explaining you that also. I'll be explaining you the different types of loops, which are nothing but your iterative statements. So you have for loop, while loop, repeat loop. For now we have all seen only for loop. In my previous lecture also I was explaining you commands, I was explaining you the programs using for loop, but then there are variations. You have the while loop, and instead of do while loop you have something called as a repeat loop. So I'll be going through for loops, the conditional statements there. I'll be explaining you joins and what is joins, how to add rows, columns, what is the factor data object. Okay, and then I'll be explaining you matrix, which is another data type or data object in R. And finally we'll be explaining you some gist about operators, so that once this is done I will be taking you through some real life examples and some programs of R, so that you will get well acquainted with how R can be helpful for solving various statistical as well as data visualization use cases. Thank you so much. Have a good day.